What is changing in the way we build today that's going to fundamentally alter the equation?
Yeah, I think if you look at construction productivity over time, this is very well known that it's relatively flat compared to manufacturing, for example. And if we and that's with rapid urbanisation, as I mentioned earlier, there's a lot more people living in cities now, in many cities in informal settlements and so on, because the construction industry can't keep pace with the need for housing. And that's not just that's a problem in Berlin, it's a problem in Copenhagen, it's a problem in London, it's a problem all over our cities. So we need to be able to build much more quickly, and at the same time do it with less carbon, half carbon now, zero carbon in 2050, and we need to do it in a different way so that we can recover the materials and keep them at the highest value. Not a small challenge, I would say, but off-site manufacture and digital manufacture are two of the components we can use. So off-site can increase productivity. If we look at the timber concrete composites, they're made off-site, they're erected very quickly and they're quite light. Next step would be to be able to recover those materials or reuse the components elsewhere. Digital manufacturing allows us to put the material where it's needed. So 3D printing, for example. But that's not just a solution in the global north, it's also global south, with 3D printed houses now appearing in parts of Africa, and the Chinese have been experimenting with that as well at scale. So there's all sorts of impacts in the way that we're building and constructing, and I think offsite is one of the keys, because then you can really take construction into the factory and get it built much more quickly when you bring it to site, and be much more deliberate about the material choices, the way you fix components together. On site, it's a lot harder to do that. That's why in situ concrete is very effective in our current construction industry. And concrete's definitely got a part to play in the future. 3D printed concrete floor plates could be, for example, build those in the laboratory, in the factory, and then put them into components in buildings and be able to recover them at end of life. We're stepping a long way towards solving some of the problems we face now.
Just give me a sense of what this looks like in practice. I mean, what is the potential impact of 3D printing? What could it mean for carbon? What could it mean for the efficiency of material use? Yeah,
so construction industry at the moment is based on, whether it's using flat plates of steel and cutting them up and welding them together, and then designing them so that you've got high stress in some parts, but probably pretty low stresses in other parts. Same with the concrete floor plate, as I mentioned earlier. You've got some high stresses in some parts, but quite a lot of it's not really doing very much. And if you can change that so you can actually just put the material where it's needed, which is 3D printing and digital design and manufacture, then you can save probably on most components. You could probably save at least half, but tending towards 30%, which is the kind of reduction we need in our built environment in terms of our material use. So it could have a really major impact.
Right.
And we've done some studies that verify that on different building components. So really potentially quite a big impact once we can scale it up. It's issues around speed of production still in terms of 3D printing and so on, but the technology is definitely there.
30 to 50% reduction in material use. That is a lot. That is impressive.
Yeah. So very simply that reducing embodied carbon, reducing material use,
sure,
and also a route to putting the materials back into the process as well. So if you've 3D printed something, quite likely you can just remanufacture with the same material when the time comes.
Right.
So it's it's a win-win really.